Hello friends, so today in this video we will create a telegram bot of blood cell segmentation. Okay, so before that let me show you how our telegram bots look like. So let me run this. Now go to your telegram bot and type start here. It will display the message like this. Now help, about. Now the main thing that to get the segmented image of the blood cells. Okay, let me select this image. Wait for the seconds because you know that for the segmentation it takes times, calculations is yours. So see the result, you will get a segmented image. You can see that each blood cell is segmented with blue color. Okay, so this is a telegram board which we will create right now. So before that let me comment whole code and I will uncomment them one by one according to the flow of the code. Okay, so that you will not get confused but which function has to be first and which function has to be at last. So the main part of this code, the main step of this code is to create a telegram bot. So I will tell you how you can create a telegram bot. Okay, let me open my browser with telegram web. uh, Go here, search for bot father, and then search for help. You will get this. Create a new bot, select the name of your bot. I am selecting blood cell segmentation. Okay, I'm copying this name. Now you have to select the username or type the username. It's up to you that you can make username as the same of your bot name. It's up to you, but the main thing is that last three character will be bot. Okay, enter. You will get a token ID. This is a main thing. This act as a link, or you can say this as a token ID which connect your Python file with the bot. So let me copy it and just replace it. Okay, now we have to create the commands. For that, let me uncomment it. See, we are using application library, using builder function, pass a token, and build. This line basically connect your Python file with your Telegram bot, and this app variable act as a reference of your bot. Now we have to create the first start command. For that, we use app handler function. In this we are using command handler library, and just if suppose a person types /start, it will activate this start function. Here this start is a function name. So let me uncomment the start function. And basically start function, when it's applying in the text format, it's actually, you can say that it is a telling the user that what is the use of this telegram bot. And you have seen that we are passing two parameters, update and callback contexts, but we are using only update, not a callback context. So the main thing is that why I'm using this callback context in the parameter but not using it, because it is a default structure of the telegram bot. Is that whenever you use this whenever you create the function with update, it is necessary to pass the parameter as a callback context. Okay, in one line you can say that it's a default structure of default structure, that whenever you have to create a command, you have to pass two parameters, update and callback context. Even you will not use them, but you have to pass them. The callback context is a toolbox which have a different tools, like if suppose I want to add some reminder in my telegram bot, or if suppose I want to uh, store the specific chat of my telegram bot, I can use callback context for that. Okay, now just right now we have created a start you can say start command. The start function will get activated. Now we have to reply the text. For that we use start update dot message dot reply text. Okay, now we will use help command. For help command, the help command tell me that which commands is used by this Telegram bot. Let me uncomment it. Okay. And you know that I already told you that for making a command, you have to pass the update and callback contents. Okay, so this is passing. And if I will not use it, suppose I will not use it, it will throw me the error that you have passed. Take one position argument or two, like something like that. You will get an error if you will not use this and just run this file. Okay. Reply text, first you have to create a text in a string format. It will tell me that which function is there, and you have to just use updated message or reply text and just pass this text here. Now we have to create the help about command. Creating the commands is the same way that we have to create the start, same way that the way we have created the start command. About command basically tell that which model the particular way train on, and what is the which backbone it is used, the way which is used by this model. You can see that we are using FCN object detection model, and the backbone is ResNet. Sorry, object not object detection. Segmentation. For segmentation model, we use FCN with ResNet 50 as a backbone. This will tell the detail of the model. Same way, just use updated message or reply text. It will reply the text, and his here markdown will be pers mod will be markdown. Okay. Now just the main thing of that is the handle photo. Now suppose a user will pass the photo for the segmentation. For that we have to use message handler as a library, and the filter photo means whenever the photo will get into the message, it filter it, and not filter the photo means here the use of the filter is that filters dot photo means whenever the photo is there, only at that time handle photo will get activated. Handle photo is a function which get activated. Okay. So let me uncomment it. Okay, now suppose for that I already know that for making commands we have to pass this two parameter. I will explain you. This line basically this line will give me the higher resolution of the photo which we pass. Okay, and it will select the photo from from the user. If suppose we pass a multiple photo in the Telegram board, it only select the one image from the among them, and it will select high resolution photo. And uh, this line basically fetch the photo from the server. Okay, now this line basically convert that not convert, it's download the image into a bytes format. Okay, into a byte stream format it download, and here this we convert that into we convert that byte stream into the numpy format. Okay, so this line first select the image among the photo which we give. This line download not fetch the image from the server. This line download the image from the download the image into the download the image in the bytes format, and here it's convert the image into the numpy format. And after that we will convert that image into a pill format and just pass it to the object detection function. So it will move compiler will move up, and here it's come. Okay, now we have to uncomment this also. We have to, because during passing this here segmentation, this Python library we are using segment function. This segmentation Python library contains one segment function that we are using. Okay, just pass the image and the color sample. Okay, it will return image with bounding image with segmentation. So go to this compiler event here. We are using segment function here. Okay, let me uncomment it. Oh, sorry, not uncomment, commented it. Now after that, first for prediction we use create model function that will return the model which we are using for predictions. So let me move it. So we are using FCN Resident 50 as a this. So for this, let me explain you that what is happening here. Okay. See, this is a segmentation model, and this last line basically act as a prediction. For that it is have 512 as an integer and 21 is a 21 is basically, you can say that it is a number of classes that particular model, pre-trained model trained on 21 classes, but we have to change it. We have only two classes. One is a background and one is a blood cell. So for that, you will go to the model, go to the classifier, select the fourth layer, and convert that fourth layer. According to us, we have an channel 5.2, and number of number of classes we have two, kernel size will be 2, and we do not require the auxiliary classifier. Okay, so that's why we are using none here, and it's will return me the model. You see that? Go to the model, go to the classifier, go to the fourth layer. We have to change this according to the number of classes we have. Okay, same thing is happening here. After getting the model, we have to load the weights. Okay, here we are loading the weights that we had used. Okay, now here model is in evaluation mode. Okay, that no updation of weights has to be performed during testing time, so that's why model.evaluation is used. And we are applying the transform, means all the data augmentation processing on the images happen during training time, that has to be performed. But the main we do not apply all the pre-processing, but just we apply the main things, that are to convert of the image into tensor, and size, if suppose there is a fixed size which we use for training, so same size has to be on a testing time, so that's why the same size which we use for the is 2 to the 4. And if by we normalizing it, because you already know now, normalize the when we normalize the pixel value, it come to in a particular range. Because of that, though no particular feature will get dominated to other feature, all features act as a balance. After this, we apply the image, a transfer to the image, and we use unsqueeze 0, because during training time, you know that during training time we pass the image in the batch format. Means the format of the image is BCHW, where B is batch, channel, height, and width. Same dimension has to be passed during testing also, so that's why unsqueeze 0 will add a dimension of batch in the image, and its batch value will be 1, because we are passing just one image. And just we used with torch, no grade, because no grade is used, no operation has to perform. And this when you pass the image, when you pass the image, it give me the output in the dictionary format. And in dictionary format, out is act as a key which give me the particular prediction of that particular image. And we have to because we are passes the one image only, so to get the prediction of that particular image, we use zero index value. After getting the output, we pass the image to the draw segmentation. To draw the segmentation on the image, we will pass that image to this function. Okay, we have passed it. Oh, let me explain this whole thing, that what is happening here. For that, let me come back to the help.py function. So suppose this is an image. So to get the red and green channel and blue channel format, you will use this 3 dot comma and 0. You will get a red channel, blue channel, and green channel. Okay, 255 1 2, 255 1 2, 255 3, 255 2, 255 3, 255 120, 64 192. This way you will get the red channel. Okay, and same way for green and blue channel, this is entire red channel. This particular column of the image is the red channel. This column is for the blue. It's not blue, green. This column is a blue. This way you will fetch red and green and blue channel. And this is a mask. Okay, mask is in a grayscale format, and here 255 and 255 is the pixels value where the segmentation is has to perform, or this is the portion where the segmented blood cells is present. Okay, just for the example, okay, I'm using it. And air overlay as as all the channels are in GB channel and have the same dimension of the image which we are using. Okay, so this is the image which we are used for explanation. Here alpha is a 0. 0.5. Is a transparency which is responsible for to add a transparency to the segmented image. Here class color, just we are giving the one to here one is index value, and 255 is a class. 255 250 is a class which we on which the segmentation perform on the image. And you know that we are passing only one, because we do not require zero background, because we don't need it. We are not have to segment the background, we have to segment the color itself, so that's why we are using passing only one with the color. And here mask, not equals to 0 is equal to 1 means all the pixels value which is not equals to 0 convert to 1. Okay, you can see that before marks is 255, but after using that particular line, the convert 255 converted to 1. And it's why we had converted it to 1, because here 1 is representing the portion where the segmentation class name class object is present, and we have only one class name, and it's represented by one index value. So that's why we have to convert all the pixels value which is greater than 2, which is greater than 0 to 1. Okay, now here we have to use the overlay. Now in overlay we will make all the red and green channel and blue channel of that according to the color we have, and it's basically represent the segmented area, segmented portions on which the segmentation had to be performed. Okay, for that we have to use the boolean 2D area. Mass is equal to class id. Here when we iterate over the class color, it will first give me the class id and the color. Mass is equal to class id because it means all the values where the all the values where it is 1 in the mask has to be true. You can see that when I have printed the class mask, it tells me that all the values in the mask where it is 1, it's turned to true. So this ultimately we get the class mask as a boolean 2D array, and when we iterate over the overlay according to its channels, means iterate 3 times 0 1 2 3. Here range is 3 because 0 1 2, and we have only 3 channels, that's why 3 value will be here. And it suppose c value will be 0 means we are fetching the red channel. So when we fetch the red channel, this red channel is in a 2D format, and here class marks is also is in a 2D format. So it will change only those portion of the of the red channel of the image to color C, means if C value will be 0, because I'm talking about the first channel, and C0 means C0 color C0 color 0 index value will be 255, means it will convert all the pixels value in the red channel of the overlay to the 255 where the class mask class marks class marks boolean class marks value will be true. Okay, see this class mask, true here, true here, true here, true here. And you already know that overlay red channel has completely blue, because have a pixels value 0, because it's a all value will be 0. So its red channel also have a 0 pixels value, so it will convert all the pixels value where the true is there according to the class mark. It convert that value will be with 255, because I'm talking about C will be at first iteration C will be 0, at C color C at 0 0 it will be 255. So you can see that red channel overlay red channel will be 255 255 255 only at that places where true will be there presented. And same way for the green and same way for the blue, you will get this, you will get the red and green and blue channel. And you can see that for the blue channel all the values will be 0, because when I were talking about the blue channel, the C value will be 2, and here color C at color C and color 2 will be there. At color 2 index value will be 0, so no changes at the blue channel of the overlay. And when you convert it into an image, you will get this type of image. Now main thing, now we have to create a blended image of the with the overlay. Now you will get confused that and one more thing, I want to explain you that all the pixels value all the pixels value in the overlay, like in the which have a greater value greater than 0 value, 255 255 255, it basically is the portion where the segmentation has to perform in the image. Okay, now you will get confused telling us that it's a segmented region has to be with 255 pixels value, and here overlay also. But the main thing is that the dimension, because the mask is in a 2D format but in a grayscale format, but overlay is in a 3D format with RGB channel. And here RGB is you can say in RGB channel we are making changes because we want a segmented image with the color and with the transparency. So this is the main thing. This is the main function which we use for converting image with the segmentation and with the transparency. Okay, so what is happening here? See, uh, This is the first calculation where we use image channel and we multiply it with the 1 minus alpha only at that portion where mass is equal to 1. Okay, so first we copy the image channel, right channel. If I'm talking about the first iteration, because I have used break, so only first iteration has to perform. So if I'm talking about the right channel only, after cutting the right channel, I will multiply it with the minus alpha, means 0.5 multiply minus 5 will be 0.5, and 0.5 means half. So all the pixels value will be multiplied with the half only at the places where mass is equal to 1. I already told you that we have to pass during calculations. I have to pass the boolean to the array. So when I am passing here 1 minus mask is equal to 1, actually I am passing the boolean to the array. And if suppose I will just pass the mask, so it will act as an index value. So it will throw the error, or sometimes your GPU will get crash. Okay, after getting it, you will get the image right channel on with the changed pixels only at that portion where the mass is equal to 1. And same way for the overlay, you will see that. Okay, same way for the overlay, same thing, multiply with the alpha. So you can see that image right channel is this way. An image, when you multiply it with 0.5 only at the portion where this true is there. In marks, true portion is at this portion, this true will be at this, true at this, and sorry, not true and not true at this, true at this, and true at this. So you can see that all the pixel values where the one is there, it does not change, but is changed, but all the pixels value where zero is there, nothing changed. You can see the mask, you can see the mask is one is here, one is here, one is here, one is here. So at only at that portion where one is there, its pixels value changes. 0 divided by 2, nothing happens. 0 divided by 2, nothing happened. 255 divided by 2, 255, same, because at this portion mask value is 0. We have to change only those portions where mass is equal to 1. So and at this line, at this row, to 1 will be presented at here. So 255 divided by 2, 127. 127.5 value will be there, but when I am printing it, it's changed its value to 127, to int value. It changes, it doesn't show the floats value. Okay, 128 divided by 2, you will get 64, because at this row 1 is presented here. And same way for the overlay. And you can see that all values where marks is equal to 1, it changed to 127.127. Okay, but ultimately you will, when you add this, when you add this and this, you will get this blended image. 255 plus 0, 255. 0 plus 127, 127. 0 plus 127, 127. 64 plus 127, 191. This way you will get the blended red channel. And if I will not use break here, you can see that you will get red and green and blue channel of the image. Now don't get confused that here 255 is there, but here 254 is there for the red channel. I already told you that here conversion of the pixels value to pixels value of red channel or green and blue channel to from float to int is after the whole process, after whole calculation is completed. Okay, then only after it's convert the pixels value to int format. Okay, so when you multiply by 2, divide by 255 divided by 2, 127.5 remain the same, and its change only after its addition of with overlay will get completed. Okay, so don't get confused about that. So I have explained the whole process, how you will get the blended image from it. Okay, now truthy lines I have to explain it. That torch.argument.output.dimension 0, it will fetch the predicted mass with the highest score from the output of the board of the model prediction. Dot CPU is why I'm using it, because sometimes when you will use this code, same code, then you can use in GPU or CPU. Or suppose you will use the GPU at that time, you want that predicted mass should be on a CPU. For that, I want dot CPU flow the data from the GPU to the CPU, and dot number I'm using it here because here prediction made by the model is in a tensor format. but for the calculation I want to convert it into numpy, so that's why I have to use .numpy, which convert the tensor data into a numpy format. After getting into numpy format, I want the my predictor mass is on the same size of the image, so that's why I first calculate the image width and height, and convert that image resize that image into the width height of the image, and interpolation dot to inter nearest, because they fill the pixels value which is empty with the nearest pixel only. Okay, now here why I'm converting the image into an image dot np, because you already know we are performing whole calculation manually, so it's required that image should be in a numpy format. That's why I'm converting it, and I have explaining whole process here. After that, we just turn the image blended image into an in a numpy format. Now again, when this function return the numpy format, compiler blend again here image with segment. Now here we encode the images into a JPG format, because you know that when we download the image we are decoded it, and same way to send the image into a Telegram bot we have to encode it. So that's why we encoded it image into a JPG format, and here this bracket tells the boolean. If suppose its value will be true, it means the function performation is success. If suppose it's false, means performance of the function is false, or something else is cost. And after that we have to convert that image into the bytes stream. So that's why we used to use this, means we are just um, reversing the process. See this, during download we download the image using bytes.id, then we have decoded it. Same way, first we have to encode it, then we have to use the bytes.id for byte stream. After getting this, after returning the byte image into byte stream, the compiler went it again here, and we get the image with the byte stream, and then the .sig will change the pointer before sending. And here we are not replying the text in a text message, so we are replying it with a photo, so that's why we use reply photo function. Then pass the image, and caption means what you want to see below the images is displayed by this caption. So I think I have explained you whole code, and let me run it again and see the result that how our board is working. Let me open it, start. See, it's showing the results. Now help, about. Okay, now let me select one image for segmentation. Let me choose this one. Wait for the seconds, it will display the photo with segmentation. See the result. You can see that all the blood cells which is segmented with blue color, and it affects only the portion where the blood cell is there. If I will not use this manually, I will not make the blood in image, so it will affect the background also. You can see if you do not use this manually, background will be get dull. Let me select one more image. See the result. Now our Telegram bot is ready, but now I will explain you what is use of this async and await in my code. Okay, so wait. So use of this await and async is that a particular whole model or Telegram bot is working in a synchronized way, not in a synchronized way. For example, if suppose I will not use suppose I will not use await here in photo.get file, and you already know that the photo.get file means getting the file from the server. If suppose I will not use this await, and whole code is in a synchronized format, and during fetching the file from the server gets stuck at some other way or some reason to server gets stuck. And during that stucking time, if I will write slash start in the Telegram bot, it will does not respond me, because at that time our whole code is working on a synchronized way until and unless this particular line will get completed. Our Python file will not respond me to my commands, which will I throw to on a message of the board. But if I will write async and await, if I will use asynchronous and await here, it means await will make the compiler say that we will do other process until this particular line get completed. If it get whenever it's complete, so whenever the server uh, send the photo, we can start from here, but during this time you can respond to the message thrown by the user. Okay, this is a use of this avoidance sync. That's why I've used also here await here, because this is also the part of the server where the message is passed from the server then to the board. And during it might be chances that server gets stuck or get crashed. And during that time, if we throw start from command and other commands, it will does not show any message. But whenever we use await here, it will throw the message to other commands if it's not responding or server gets stuck during this particular line execution. So I had explained you each and everything here. What is use of each line, what is line in detail way I explain you. Okay. So please like, share, and subscribe to more videos like this where I will explain you each and every line in detail way. Please like and share. Thanks to you all.